Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. So as we're continuing guys with our organic reactions, and we looked previously in the last two videos, we looked at the oxidation, which is the combustion of alkanes, as well as the esterification. If you haven't grabbed hold of those videos, you need to grab hold of them because they are very important in your organic reactions. Now in this one, we are looking at the addition reaction. And when we are looking at addition reaction, I'm going to take you through the process of that. But before I do so, I will encourage you, subscribe. Go on and subscribe. If this is your first time and you are not yet subscribed in this channel and it is bringing value to you and you are learning a lot, I think the best thing you have to do is to subscribe so that every time there is a new video, you are easily notified. YouTube notifies you every time we post a new video. Also, it's very good to ensure the notification bell is turned on. You guys, one of the best things you can do to someone is sharing this channel to them. Let it be a gift to them. The best thing you can do, you can't give your friend anything else, but give this as a gift to say, I came across this channel, I think it can benefit you. And you never know what it can do to someone. Next time they're getting their results, they will thank you because you showed them this channel at the end of the year. Now look at this again. Reactions in organic chemistry, we are looking at addition reaction, and we are looking at addition reaction in what? In alkenes. Addition reaction, it's in alkenes, addition. So I think the word is specific, addition, you are adding. Okay, it's addition, so you are adding here. So when you're talking about addition reactions, I just want to show you from this picture. You see, alkenes means what? They have a double bond. Now the fact that they have a double bond, it means it is possible to break one of these bonds. We can break it. Let me make it bigger. We can break, actually let me break the bottom one. If I break that bond, right, and as I said, the word is I'm breaking it. You break that bond. When you break that bond, you'll be left with one bond now, which is, in this case, is this bond. Let me make it big. You have got that bond as 1, 2, 3, see that? 4, 5, and now the one that are broken, you see, there is one bond and one bond. So in each carbon, it's 1, 2, 3, 4, and then on the other carbon which is broken, it's 1, 2, 3, 4. Now look, this is the picture I'm having. We have got that bond, and then it is the one that was broken. See, it was the double bond like this. You see that? So initially what you had, this bond was one thing like this. It was a double bond. So when it was broken, it became one bond in the center. It is now a single bond, and then you've got that this carbon has got 4, as well as this carbon has got 4 bonds. So the main is 1, which is linking the single bond, linking the two carbons together, and then you've got 1, 2, 3, and 1, 2, 3 extra bonds, making this carbon have 4 bonds. So that's what is happening. So if I can quickly put this in a way, just as a simple picture for you, what we have is, suppose we have got ethene here. So this is what we're having, ethene. Now with this ethene, for example, let's add hydrogen, for example. It's hydrogen. Then when we're adding hydrogen, hydrogen is going to come in here. Just want to show you. Hydrogen is going to come in and break this bond. So you're coming with hydrogen and hydrogen. When the bond breaks, one of it will go there and one of it will go there. So let me erase the center one here. So that is what is going to happen. And then the final structure that you're going to come up with is going to be like this. You see that? That is what actually is happening there. So from ethene, from alkene, what do you form? Alkene, which is ethene, you form alkane, which is ethane. That is a reaction. So what I've just did, I've gone ahead of myself and explained to you this reaction called hydrogenation. Now hydrogenation is the addition of hydrogen to an alkene, just like what we did here. You see, addition of hydrogen. This is hydrogen because it is H2. That's hydrogen gas. Now, for you to be able to do this reaction, there is a condition. For example, the reaction conditions for this reaction, you need hydrogen and platinum or what? Platinum or nickel catalyst. Sometimes it's palladium. They also accept. Also, alkene must be dissolved. This alkene here, it must be dissolved in a nonpolar solvent like hexane or benzene. So here, this alkene, you dissolve in, for example, hexane, which is common to you, or benzene. It's a common. You're no longer doing cyclo, but benzene is a structure like this. You guys are no longer doing this structure. It used to be there in the old syllabus, but it's no longer happening here. So you've got benzene, but just out of interest sake, this is benzene, you know. So if you're drawing benzene, you just do this, you do that, you do this, you do this six-sided cycle. Then you do one, you jump, do two, you jump, you do three. This is benzene. Okay, and then in here, these are carbons, 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 carbons. It's a cycle structure, but you don't no longer do that. But anyway, forget about that. I'm saying you dissolve alkene in a hexane, and then or benzene, and then hydrogen. This hydrogen, what you need, remember the catalyst, very important. The catalyst is platinum catalyst, which is needed, or sometimes you can put nickel or palladium, PD. So it depends. Then you can form this alkene. The reaction conditions, guys, are very, very important. They will ask you what catalyst is needed or what are the reaction conditions. You must remember they need you to state the nickel and the palladium catalyst. So this reaction, as I showed you, how does it happens? It's simpler. Let's talk about we talked about ethane. Let's talk about propene. So if I've got propene, which is like this is my propene, right? And then I've got my hydrogen. So we have got propene here, propene as an alkene. So this is my alkene. Are you with me? So when I'm reacting an alkene, the addition of hydrogen to an alkene, so I'm adding, so plus I'm adding hydrogen, but I cannot write it like this. Why? Because they want it in structural formula. Then I must write it as H. That then what is the final product? Don't forget here I need platinum or nickel. You need to state that, and then after that you need to break that bond. Then you come up with just single bonds all through, single bonds. So you've got hydrogen, single bonds, single bonds. That's all they want to see there. All right. So what type of a reaction is this? They call this reaction hydrogenation. So that is now propane. So it's hydrogenation. That's what they do, and they will ask you what is the importance of this. Number one is used in the formation. Hydrogenation is used in the formation of margarine. The rama that you eat, the flora that you eat, or any type of margarine that you are eating is formed from hydrogenation. Just remember that. They use it in the formation of margarine, or it used in oils. Hydrogenation of oils, that's where you form different products such as margarine. That's the first part. So don't forget, what are you having? You are moving from an alkene, which is propane, to an alkane. So it's hydrogenation. So if they say to you a simple reaction, alkene plus hydrogen in the presence of a platinum catalyst or nickel catalyst, and then what are you gonna form? You're gonna form an alkane. And what's the name of this reaction? It's hydrogenation. From that word, hydrogenation, it's what? Addition of hydrogen. Yeah, plus H2. You are adding hydrogen. Alright, I hope this you remember. Let's move on to the next addition reaction, which is important for you to know. The next one is halogenation. Now there is that word halogen. You know the two halogens, addition of a halogen, bromine and chlorine, bromine or chlorine. Sometimes iodine is also involved, but now they will ask you why are they not adding it. It's because the reaction is very slow. You remember now on the intermolecular forces and everything, we start from F2 and then we go to, I think it's Cl, then we go to Br, and then we go to I. Now Cl2, Br2, I2. Now if you look at this is small molecule and this is large molecule. When you start looking at the intermolecular forces and the energy needed for a reaction to take place, you will discover they didn't put fluorine because this reaction is explosive. It's very volatile reaction, and then this reaction here is slow on halogenation. Why? Because the smaller molecules react faster. The higher the surface area, you talk of the surface area, and then the smaller the surface area, the higher the surface area, the faster the rate of a reaction, making it too fast. And then on the iodine, because it's a bigger molecule, the reaction is slow because it has got a smaller surface area. So you can link this to the intermolecular forces. Alright. Now, so they usually say the best one to have is chlorine and bromine to an alkane. Reaction conditions, what you need just a halogen solution here and room temperature, but avoid water. You don't want water here. Water, no water, because you can end up forming other substances. It's just a bromine solution. Now how do we go about this? Usually they will tell you that this alkane, then you dissolve it in a non-polar solvent like hexane or benzene. So how does it go? Similarly what we did with ethene, it's not complicated. You take your ethene. This is the first one that was common that we did. You take your ethene plus Br. Do like this. Can be chlorine, anything of those two. And then usually, as we say, it is room temperature. And then what you have? 1, 2. Okay, that's it. Okay, let me put this properly. So what do we have? We have got 1, 2 hydrogens, the hydrogens. So these are the 4 hydrogens. Remember, I'm breaking one of the bonds. For example, I'm breaking that bond. You break it. So when you break it, you are creating 2 new spaces here. That's where this Br comes there and the other Br will come there. So that's why you have got the Br, and what do you have? You have the other Br. I hope you saw what I did there. Then what do you have here? You have got ethene, and then you have got bromine. And then what do you have? You have got here 1, 2 dibromoethane. Please don't form it like this. It won't be correct. I'll make it in red. Don't do this. You can't form it to say I've got Br here, and then I've got Br here, and then you've got that one, and that one. This one will not form, which is a 1,1 dibromo on the same carbon, dibromoethane. It won't form. Why? Because when you are breaking, you are leaving 2 empty spaces on each carbon, right? Not on the same carbon. So you are going to form, the bromine will attract itself to the different chlorine. Alright, so if I can try another one for you, just a quick one, with chlorine. For example, if I say you have got here this structure which is but2ene, you have got this but2ene. Alright, there is a structure. This is but2ene, and then you have got chlorine in here. And then what are you gonna have? Simple thing, as it breaks there, you're going to have 1, 2, 3, 4 in here. That's where you'll have your chloro, right? Then the rest is your what? Is your hydrogens. Is it making sense? I hope it's making sense, guys. You can try it. And then when it's like that, what do you have? What's this? You need to know the name of this. This is 1, 2, 3, 4. So it's 2, 3 dichlorobutane. It's a haloalkane. So what are you forming here? So they are saying halogenation. So we are forming from an alkene to a what? Haloalkene. It's addition reaction. This is addition. Are you with me? So you need to be able to do that. Now, if I say to you, try this one for me and tell me what you're gonna get. If you're forming propene, this is propene. Try this one for me. You've got propene here, and then plus a halogen, Br and Br. What are you going to form? Just do that for me and tell me what is the product that you're going to form. Can you do that for me? What will be the name of that project? Give me the structure as well as the name. Structure and name, the IUPAC name of that product. What you're gonna form. Even here on the addition that we did previously, can you do this one for me? If I said you have got an alkene, which is this one. You fill up with hydrogens here. You've got this alkene, and then I want you to add hydrogen. What will be the name and the structure of that product? So 1, 2, 3, 4, 5. You know what is this name? Tell me the name of this one and the name of the product. All right. So having done that, let's look at the next one. Hydrohalogenation. See the word hydrohalogenation. What does that word hydrohalogenation? It means you are adding in here HX, where X is equal to the halogens we talked about, F, Cl, Br, and I. You see, halogens. So it's HX, which means you can look at products such as HF. This is a hydrohalogen. HF, HCl, HBr, HI. These are hydrohalogens. So you are adding these. You are saying plus this. So they are saying reaction of a hydrogen halide, which is hydrogen halide, to an alkene. Reaction conditions: an alkene must be dissolved in a non-polar solvent, important again, like hexane or benzene. No water must be present to avoid formation of alcohols. Don't forget. Then we're going to discuss this issue of what? Major and minor products. Remember the reaction conditions. No water in case you form alcohols. We'll discuss it in the next one, which is called hydration. And then non-polar solvent is needed, such as benzene or hexane, so it can happen at room temperature. Now hydrohalogenation, they talk about major and minor products, but before we do that, let's simply deal with one. Ethene, that's our starting point. If I say you've got ethene here, this is ethene. Are you with me? plus, what am I adding now? I want to add hydrogen bromide, right? But I want it in structural form. Is HBr. What is it going to be? Look at it. When I break it, it becomes like this: hydrogen, hydrogen, C, hydrogen, hydrogen. Then you have got these empty spaces created. That's where the hydrogen comes there to fill up here. The bromide comes there to fill up there. Are you with me? And then you've got ethene. And then in here, you have got bromo, ethane. So it's a haloalkane. So here it's a haloalkane from a what? From an alkene to a haloalkane. But what we call this reaction is called the hydrohalogenation. Why? Because we added hydrogen and we added a halogen. That's why it's called hydrohalogenation. It's an addition reaction. But it's a very, very sensitive reaction because, as they say, it says there is major and minor products. I just want to discuss that with you. Major and minor products. Let's look at again hydrohalogenation. And then here we are focusing on major and minor. Major and minor product. Let me bring it down here. Major and minor what? Products. Now, what do we mean when we talk about major and minor products? Now, pay attention now. Pay attention. Let's say I've got, it was easy with ethene in the previous one. It was easy because, you see, it's just a symmetrical molecule. It's CH2 and CH2. So the carbon has got two hydrogens, the carbon has got two hydrogens. It's not a problem here. So there is no major, there is no minor. But when we start looking at different molecules like propene, prop 1 in, for example, I'll do it like this. This is propene. Let me do it like this for propene. C, that, and I've got this one, I've got this one, I've got this one. Here I've got the hydrogen. Now, plus, let's repeat again, HBr. But let me put it down here because I want you to get what actually is happening. Plus HBr. Let's use this one, HBr. Now I want you to pay attention. Now there is this rule called, I don't know the spelling, but it's something like this, Markovnikov's rule. This is Markovnikov is the one who came up with this concept, Markovnikov. But I usually use this one. It's a biblical concept. It says, to those who have more. It's in the Bible, guys. To those who have more, what does it say? More shall be given. More shall be given. So it's Markovnikov's law, but I use this rule. To those who have more, more shall be given. What is it? What is happening here? What am I trying to say? This is how this whole reaction happens. Look at the two carbons. There are two carbons of interest. The first carbon of interest, I'll call them carbon 1. No. We name them from the group closer to the double bond. This is carbon 1 and this is carbon 2 and that is carbon 3. I want to focus on carbon 1 and carbon 2. That's where the reaction is going to happen. When this reaction breaks, remember we did mention that it will break. So it's plus. When it breaks, it becomes like this. C, hydrogen. And then here I have the hydrogen. And then because it broke there, I've got this hydrogen and I've got this hydrogen. Now I've got empty spaces here. I've got two empty spaces here. and here. Those are empty spaces. Now the question is, you need to understand there are two possible products here that are going to form. Let's say, out of interest sake, this hydrogen goes there and this Br goes there. So you see the product that is going to form? You're going to have this product whereby the hydrogen will be here and the Br will be there. And then at the same time, what if the opposite happened? Let me take it here a bit here. What if, then I'll say, or we can have another product similarly, which is I want my space to fit well, so I'm gonna draw it separately here, which is C1, 2, 3, hydrogen, 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 hydrogen. Why am I drawing like this thing is skewed up? Sorry about that, but look at this. I think it can fit here. C, C, C. Hydrogen, hydrogen. Yes, we are getting there. We are getting there. Hydrogen. Now here, look at it. What if it interchanged so that the Br went to 2, the hydrogen went to that one, to couple number 1. So if the hydrogen went to couple number 1, what is it? It's going to be here, hydrogen, and the Br is here. That's where the concept of major and minor products are coming in. Now the question is, which one is preferred over which one? Then that's where this Markovnikov's rule, to those who have more, more shall be given. What does it mean? Your focus is, let's go back to the structure. Let me draw it again, the structure. I'm gonna draw it again because now it's mixed up. This structure was like this, right? It was like this. I just mixed it up, guys, so I'm trying to redraw it. This is the structure that we have. Then it says, to those who have more, more shall be given. Or Markovnikov says the hydrogen will be attracted to the carbon with the highest number of hydrogens already. I repeat, it says the hydrogen atom will be attracted to the carbon with already the highest number of hydrogens. Now looking at carbon 1 and 2, how many hydrogens does carbon 1 have? It's got 1 and 2. And how many hydrogens does carbon 2 have? It's got only 1. So which means, according to Markovnikov's rule, the hydrogen will like to go to where there is already more carbons, which means the hydrogen will prefer going here. You see that? And then which means the bromide will prefer going there. As I said, to those who have more, more shall be given, meaning this carbon 1 already has got more hydrogens and more hydrogens are given to it. The opposite rule is true. The hydrogen with the smallest, the carbon with the smallest number of hydrogens or the least number of hydrogens will attract the bromide, while that is the opposite is the hydrogen with the least number of hydrogen will attract the bromide. And the hydrogen, the carbon with the most number of hydrogens will attract the extra hydrogen. Are you seeing that? It happens in here because if it was hydrogen, it doesn't matter, but it comes in now when we've got hydrogen and another different atom. That's why it calls that. So from here, we can now come with the major and minor. This then becomes major product. See that? Why? It's the same. It took this concept. The hydrogen went to where there are more hydrogens. So this carbon 1 had already 2 hydrogens and the third hydrogen went to it. So there are how many now? 1, 2, 3. But now the minor product is this one, whereby the hydrogen went to the carbon with 1 hydrogen. So there are 2. So this becomes the minor product. And it follows what? Markovnikov's rule. Don't forget Markovnikov's rule. Do you want us to do another one? Can you try this one? Try this one. You are given a compound like this. There is the compound, is butene, Alright, you are given butene, and with this butene you are adding plus hydrogen chloride. Now, can you predict which one is the major product and which one is the minor product? Can you do that for me? Pause this video and you do that for me, and I'll quickly give you the answer. Which one is the major product and which one is the minor product? So which means you need to come up with two products. So pause the video and do that for me. Hydrogen chloride. So let's do it. If you pause the video, you're supposed to come with something like this. Hydrogen. So this is always the best. Break it first like this and ask yourself, if this one is broken, where do I start? So the first one, hydrogen, I want it to go there. Make it hydrogen, let it go there. The chloride there. Then the second one will be similarly like that. Okay. Always fill up the hydrogens properly. So here we don't know here. Now you do the opposite. So you are saying chlorine will be here now, hydrogen will be here. Obviously must be opposite. But look at it. The hydrogen loves going to the carbon already having more hydrogen. If this was carbon 1, 2, carbon 1 has got what? 2 hydrogens. So the hydrogen loves these 2 hydrogens. It likes to be attracted to its company. To those who have more, to this carbon that has more hydrogens, more shall be given to it. And the one that has got least hydrogens attracts chlorine. So this is the major product and this is the minor. Look, chlorine went to the carbon with more hydrogens and it becomes a minor product. Minor means it doesn't like to be formed. Major means it's the most product that is formed. So you might find that here you have got 90% and here you have got 10%. Are you with me? What are these? These are positional isomers, guys. Positional isomers. Look at the position of the what? Of the functional group, which is chlorine. So positional isomers, what will you call this structure? You'll call this structure 2-chlorobutane. Do you see this? And what will you call this one? 1-chlorobutane. So 1-chlorobutane minor product, 2-chlorobutane major product. And then what was this? This was butene. And what type of isomer these? These are positional isomers because the position of the functional group chloro is changing. Sorry guys, this lesson will be a little bit longer, but just bear with me because I just want to put this concept together. The last one, so that you put it all together as one. It is hydration reaction. The last one of addition reaction is hydration. It also follows Markovnikov's rule, which says the hydrogen, carbon with the most hydrogens will attract the extra hydrogen. But you see that. Reaction conditions, now this is very sensitive. You need sulfuric acid, strong acids, or phosphoric acids. This is phosphoric acid. And the other one is common, sulfuric acid. Sulfuric acid, you need to know how to write it, and phosphoric acid. Now also see, it has got major and minor products. Let's start with the first one. They call it hydration. Now hydration, if you're hydrating yourself, means add what? Add water. That's what hydration means. Addition of water. If I say I'm thirsty, what do? I need to hydrate myself. That's why when you are lacking water, they say you are dehydrated because you don't have lots of water. But if you are hydrating yourself, you are doing the opposite of being dehydrated. You are taking in water. Look at this. If we've got the simple one, we started like this. Ethene. Alright. And with ethene, now you add water, H2O. Remember, this is the H2O. If I'm drawing the structure like that. Now, what do I have? Now, H2O, it's simpler like this. It's more like this. It's more easier like this to say HOH. So, what do you have? The first part, will go, okay, let me do the other side. So you'll have this hydrogen, 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 hydrogen. So you see, there are two parts how you break this water. The hydrogen will come there so that it becomes like this. Remember there are two spaces, so it will come in here, so it becomes hydrogen. Then this one will come in here to become OH. And what is this? This is an alcohol, guys. So that's how you form an alcohol. When you take an alkene, you hydrate it or you add water to an alcohol. So this is ethene. What it becomes? Ethanol. Are you with me? Alcohol, ethene, ethanol. But now let's bring in this part of major and minor product. If I start complicating it like I did previously, to say I've got a structure like this, which is propene, right? I've got propene, right? And then with propene, then I add, I forgot to do that one thing. I say plus, what do I add? I add H2O, which is HOH. Right. Now, what do I form? What do I form here? Let me do this. Let's make it center so that it becomes, when I've got this, what is it that is going to be formed? Don't forget the condition is H2SO4, very important, or H3PO4. Phosphoric acid or sulfuric acid, very important reaction condition. They will say what is the condition for this reaction to take place, or a catalyst that is needed. So you have got that, sulfuric acid or phosphoric acid. Look at this now. That's where we come up with the major product, and then we also have the minor product. I just want this a little bit in here. Major product and minor product. Look at the major product and the minor product part. Two things are going to form. You're going to have 1, 2, 3, and then let me put it down here, the other hydrogens. We're going to have two empty spaces there, or you have got the same 1, 2, 3, two empty spaces. It follows what? Markovnikov's rule. The carbon with the most number of hydrogens will attract the hydrogen. That's the Markovnikov's rule. To those who have more, to the carbon that has got more hydrogens, more shall be added to it. Now, let's study these two carbons. We have got weight was carbon 1, carbon 2, carbon 3. Even here, I've got the same thing, carbon 1, carbon 2, carbon 3. Now, look at carbon 1 in the first one. It has got how many hydrogens? It has got 2 hydrogens. Already, it has got the most hydrogens compared to carbon 1. Carbon 2. Carbon 2 has got 1 hydrogen. Carbon 1 has got 2 hydrogens, meaning it will attract this hydrogen to it. To those who have more, more shall be given. And then the other OH will come here to become OH. Are you seeing that? The opposite is true. 1, 2, 3. If the opposite is true, the OH will come here. The hydrogen will come here. Look, this hydrogen in carbon 2, the carbon 2 has got only 1 hydrogen, but carbon 1 has got 3. So this is the minor product. It doesn't like to be formed. You can find less, maybe 10% of it, and then 90% will form the major product. This is now our major product. Major product. That's the most product that will be formed. And what did we call this? We call this positional what? Positional isomers. These are isomers. Same molecular formula. Remember, isomer, different structure. What is their name? If I look at the name, this is 2. No, I don't want to start with 2. That's the wrong way of naming. It's fine to say 2-ethanol, but it's propanol actually. It's propan 2-ol, and this one is propane 1-ol, but which is propanol. It's fine to write it propanol. Propane 1-ol, just to be specific, to say it's in propane 1-ol. But even if you say propanol, it's automatically meaning it's propane 1-ol. Propanol or propane 2-ol. Positional isomers. Now what do you say? Hydration means if you add an alkene, it passes through hydration. What do you get? Alcohol. Major and minor product. And then you ask myself, why is it that there is no major and minor product in this ethene? Look at it. This carbon has got 2 hydrogens. This carbon has got 2 hydrogens. So it's a symmetrical molecule. Doesn't matter. It will still be ethanol. I mean, doesn't matter whether you say ethane 1-ol, you start from here 1, 2, or the other way around, you still get ethanol. Are you with me? Can I give you one to try? Can I give you one to try? I want you to try for me this one. Butene. Try for me this one. Right. And you tell me what is the major product and what is the minor product you're going to form. And then you're hydrating it. You're adding water, HOH. But just out of simplifying things, I'll say add H2O. And you know the reaction conditions, it's what? Because there are conditions here, let me change it. It's what? Phosphoric acid. Just let's say phosphoric acid. What are you going to form? 2 products, minor, major. Can you pause the video and see if you can match the answer that I'm going to have? Just pause the video and check your final answers. Alright, so sometimes you get tired of writing these hydrogens, but they are very important, eh? And there we go. Now the H will start there and the OH will come there. We do the same thing here. The major and what, guys? The major and the minor. So in here the OH here and the H here. Now which one is the major? This becomes my major, this becomes my minor. Why? According to Markovnikov's rule, this hydrogen went on to be attracted to the carbon with already 2 hydrogens. Alright, but here it's okay, I forgot a hydrogen here. Here there is the 2 hydrogens. This carbon already has got 2, but it cannot attract. No, it can attract the OH. It will attract the hydrogen. So guys, that's how you go about it. These are positional isomers. Can you state their names? What's the name of this one? Can you try it? It's 4 is butane. So it becomes what? Butanol. Butanol. What about this one? It's what? Butane what? 2-ol. You're right. Butane 2-ol. If you must be able to pick up that. So guys, we have come to the end of our addition reactions. We were looking at what? We started by looking at I think it was hydrogenation, halogenation, hydrohalogenation, as well as hydration. Very important addition reactions. It's one of the longest lessons I've done so far, but I wanted you to catch it at a moment so that when you sit down, you'll be able to look at it as wholesome. But now when you are studying this, don't sit for 40 minutes. It will confuse you. Just do it in 24 minutes, get a break, come for the next 24 minutes again, and you'll be able to grasp everything. And as I say, that's why it's called the 24-minute lesson. It is for the underdogs. So if you are an underdog in this subject, you are the right candidate. So take your time. You don't need to hurry. Just take your time. That's why I say subscribe, so that you can be notified every time I'm posting a new video. If you guys are not subscribed, you will lose quite a number of lessons. And I want to bring these to you as much slower as I can. I hope this is of benefit to you. We've come to the end of our lesson. See you again in the next lesson. Oh yes, in the next other lessons coming. Remember what we're dealing with. We're dealing with what? Let me show you. and I think I did mention to you that we are looking at these reactions. Yes, it was these reactions here. So let me go back. Okay, that's not the one. I think that's not the one. These are previous lesson, but I think it was here. Okay, maybe I mixed it, but look at this. In the beginning I said we are looking at organic reactions, and in these organic reactions we said there are different types. We looked at the first one, which was oxidation, in the previous lessons, and then we looked at esterification. Now we looked at addition. Now the next one is to what? We have to look at what do you think? After adding, what do you think? Elimination. Very important, is the opposite of addition. And then we'll look at substitution. These are still missing, as well as lastly cracking. Catalytic cracking is also part of it. Cracking. We'll look at cracking. I didn't put that, but the last one is polymerization, formation of a polymer. So if you guys are not subscribed, unfortunately you're not going to benefit from this lesson. The next lesson will be also as important as the addition reactions, and it follows the major and minor product scenario. I will encourage you to grab hold of it. We've come to the end of our lesson. Thank you.